Hi everyone, my name is Banu Kadirova, and in this presentation I'm going to talk about how human responds to bilateral asymmetric hip stiffness applied by a robotic hip exoskeleton. So the purpose of the study is to test whether applying bilateral asymmetric hip stiffness by a hip exoskeleton can elicit neural adaptation, which is a critical component of gait rehabilitation. And if it does cause any kind of neural adaptation, our second goal is to assess whether that adaptation is driven by the nervous system, reducing gait asymmetry. So here you can see some of our results. On the right part, you can see step length asymmetry. And on the left side, you can see the result of our prior study, which was done with unilateral stiffness configuration. So if you look at both of these plots, you can see that bilateral stiffness configuration can cause stronger signs of neural adaptation. And this can be noticed by having larger immediate response during on early phase. As you can see from the plots, there was 4% change in step length asymmetry, but with unilateral stiffness configuration, there was only 2% change in step length asymmetry. And participants were also converging towards symmetry from on early to on late phase. However, it wasn't very clear if subjects were converging towards symmetry with unilateral stiffness configuration. And there were also stronger after effects with bilateral stiffness configuration. And having bilateral stiffness configuration also helped to eliminate the baseline asymmetry, which we observed with unilateral stiffness experiments. So apart from spatiotemporal parameters, we also looked at kinetic parameters. More specifically, we looked at braking asymmetry and propulsion asymmetry. And here from this plot, you can see that we observed similar trends as in prior split-block treadmill studies. So as in split-block treadmill studies, we also observed greater change in braking asymmetry compared to propulsion asymmetry. And the direction of the change was also similar with split-block treadmill studies, as you can see from the left plot here. There was a decrease in braking asymmetry from 0 to negative 15% during early adaptation, but then it converged back towards 0. And we also observed the same similar trends with bilateral stiffness configuration, where braking asymmetry reached negative 10%, and then it reduces back towards its baseline value. So having changed in spatiotemporal parameters as well as kinetic parameters means that applying bilateral stiffness configuration can be potentially used for gait rehabilitation.